Okay. So in section 5.4, we are going to add and subtract what are called polynomials. All right. What are monomials? We've already worked with monomials. They are just one-term variable expressions. So if I give you 5x squared y cubed, what would be the degree of this monomial, 15x squared y cubed? What would be the degree? Fifth degree, 2 plus 3. That would be a fifth degree monomial. You are correct. All right. So monomials are just one-term expressions. How about negative 11 or 11 or negative 11? What's the degree? What's the degree of a constant?
0.
0. All right, ladies and gentlemen, what is a binomial? Bi means how many? The prefix bi means
2.
2. So binomials are two-term variable expressions. So here's some examples of some binomials. 2x plus 7, that's a binomial. Now the degree of a binomial is equal to the highest degree term. This is a first degree term. This is a 0th degree term. So we would say this binomial is of degree 1, first degree. That's a binomial. Here's another binomial. Negative 3x squared plus 4x is an example of a binomial. Binomials are two-term variable expressions. Terms are separated by subtractions or additions. What would be the degree of this binomial? What's the highest degree term? This is a second degree term. This is a first degree term. So what would be the degree of this binomial?
3.
No, it's going to be equal to the highest degree term. This is a second degree term.
Okay, so 2.
This would be a second degree binomial. Okay, second degree. All right, here's another example of a binomial. One half xy cubed minus 2/3 z. What's the degree of this first term? The degree of this first term would be
3.
1 plus 3, fourth
4.
degree. And what's the degree of this term? Just 1. So what's the highest degree term? The highest degree term is what? 4. So this would be an example of a fourth degree binomial. All right. Trinomial. Tri means how many?
3.
3 term. So a trinomial is a 3-term variable expression. Examples of some trinomials, 3x squared minus 5x plus 22. This is an example of a trinomial. What's the degree of the first term?
2.
Degree of the middle term is 1, and degree of the constant term is 0. The highest degree term is 2, so this would be a second degree trinomial. Second degree. Furthermore, we say this trinomial is written in descending order. What does it mean to be written in descending order? Well, that means the degree of each term decreases. from left to right. So this trinomial is written in descending order because we have a second degree term, first degree term, 0th degree term. That's a trinomial. Here's an example of a trinomial. Negative 2/7 x squared y cubed minus 5y cubed minus 12. The highest degree term would be this first term, which is of degree 8. So this would be an 8th degree trinomial.
So we automatically choose the highest degree on binomial.
Yeah, the highest degree term. Yep. So the degree of a polynomial in general is equal to the highest degree term. So all of these are examples, ladies and gentlemen, of polynomials. So polynomials include monomials, binomials, trinomials, and all other polynomials. In other words, there's really no limit to how many terms you can have in a polynomial. Some polynomials have an infinite number of terms. We don't really work with infinite termed polynomials in here, but they do exist. All right, so what are we going to do with these polynomials? Well, we're going to add and subtract them. And in order to add or subtract polynomials, we add or subtract like terms. We add or subtract like terms. So let's try one out. Let's take this binomial, 2x plus 3, and to it, let's add this other binomial, which is negative 10x minus 14. So what is it that I can only add together here, ladies and gentlemen? I can add only the what and the what's.
The x's, so 2x
You can only add the two x's,
and the 10.
the 2x with the negative 10x. Those are like terms. And we can add our constant terms. We got a 3 plus a negative 14 here. 2x plus a negative 10x. Negative 8x. 3 plus a negative 14 plus a negative 11. So negative 8x minus 11 would be the sum of these two binomials. Any questions how we just added those binomials together? Okay. Subtraction works essentially the same way. So if I take this trinomial, which is like 5x squared minus 11x plus 13. If I take this trinomial here, and suppose I want to subtract off from this trinomial, this binomial here, negative 9x minus 20, okay? So how would we subtract these polynomials here? Subtracting this binomial from this trinomial. Well, we learned a long time that subtraction is the same thing as adding the what? Subtraction is accomplished by adding the opposite of what's being subtracted. So what's the opposite of negative 9x minus 20? What's the opposite of negative 9x? Positive 9x. What's the opposite of negative 20? Plus 20. Now to add these together, these two polynomials, this trinomial and binomial, we can only add together like terms. 5x squared has no other like term to add to. So we just bring it on down. This negative 11x will get added to what other like term? Plus 9x? 13 will get added to 20. All right, so when you add this trinomial and binomial together, you're going to end up with 5x squared. Negative 11x plus 9x is minus 2x, and 13 plus 20 is 33. That would be the difference between those two polynomials. The difference between this trinomial and this binomial. So subtracting a polynomial is equivalent to adding the opposite of each term of the polynomial. Any questions how we did that problem there? Okay. Okay, so let's try another one here. Any questions on this page here so far? Okay. All right, let's try to subtract these trinomials here. So the instructions will say subtract. All right, so how would I subtract these trinomials? Could change subtraction to what? Addition and add the opposite. So 3x squared plus 1x plus 4 minus this trinomial could be equivalently written as 3x squared plus 1x plus 4, change subtraction to addition. But in changing subtraction to addition, you have to add the opposite of each of these three terms. The opposite of 1x squared, negative 1x squared. Opposite of 2x, minus 2x. Opposite of negative 3, plus 3. Now to add these trinomials together, we can only add together like terms. So I can only add 3x squared and negative 1x squared. Feel free to regroup these like terms inside separate parentheses. You can always do this. 1x plus a negative 2x. And 4 gets added to 3. Therefore, 3x squared plus a negative 1x squared is going to be 2x squared. 1x plus a negative 2x is minus 1x. 4 plus 3 is 7. Ladies and gentlemen, that would be the difference between those two trinomials there. Is this making sense so far? Adding and subtracting polynomials. All right, let's see. What we could do is we could try classwork number 1. Today is November 10th, 2021. And we will try to do a couple of these problems. I would like you to simplify these. Problem number 1. See if you can take this trinomial. And subtract off this trinomial. Hold on a second. I wanted this to be a minus 6x.
Is that 4x squared or 4x cubed?
Oh, that's 4x squared here. This is 6x cubed minus 4x squared plus 2x minus 9x squared minus 6x plus 3. See if you can do that problem. And then see if you can simplify this one here. All right. So see if you can do those problems. We'll call that classwork number 1. Okay, anybody get the answer for the first one? This one? Subtracting a polynomial is the same thing as adding the opposite of a polynomial. So change subtraction or addition, then they add the opposite of 9x squared, which means we add negative 9x squared. Subtracting a negative 6x is the same thing as adding a positive 6x. Subtracting 3 is like adding a negative 3. All right, now we combine like terms. Notice our 6x cubed term has nothing to combine with. There is no other third degree term in here. So we just bring it down as part of our answer. And now we have some second degree terms that need to get together. We have a negative 4x squared that must be added to a negative 9x squared. We have some first degree terms here, 2x, that must get added to 6x. And then we have a constant term at the end here, plus negative 3, that has nothing to combine with. There is no other constant term, so you're just going to bring it on down. All right, so now what's we have, therefore, we have, we're going to have 6x cubed. Negative 4x squared added to negative 9x squared is a minus 13x squared. 2x plus 6x is plus 8x. Plus a negative 3, I'm just going to go back to saying minus 3. Did anybody get that for the first one?
Yes, I did.
All right.
I didn't, but I messed up at the top, but I see what I did wrong. I didn't change. I didn't
Okay.
flip my 9 to a negative 9 or my
Yeah.
3.
Yeah, when we change subtraction or addition, we're adding the opposite of each of the terms inside the parentheses here. So you got to change all the signs. Just toggle the signs. This becomes a negative, this becomes a positive, this becomes a minus. Okay. All right. So that one's good there. All right. How about the second one here? Notice we're being asked to add two trinomials together, this trinomial and this trinomial. 5a squared needs to be added to a 4a squared. Feel free to, rearrange your terms and group them together inside parentheses. You can always do that. Negative 2a must get added to a minus 3a. Plus, and then the 7 must get added to 2. All right, when we take care of the addition here, we're going to have, this is going to add up to 9a squared. Negative 2a plus a negative 3a is a minus 5a, so we'll have plus a negative 5a. 7 plus 2 is 9, so plus a 9. Now your author in the back of your book is not going to leave it written this way. The author, instead of saying plus a negative 5a, is just going to say minus 5a. So we'll say 9a squared minus 5a plus 9. Did anybody get that for an answer?
Yeah, I got it.
All right, it's great. So adding and subtracting polynomials is what we're doing here. Okay. That's classwork number 1. Now, sometimes, your polynomials might have some messy decimals or fractions in them, but we don't change the way we proceed. In other words, if I have 5/9 x cubed plus 1/3 x squared minus 2x plus 1, if I take this 4-term polynomial, notice there's 4 terms in this polynomial. So we don't have a nifty name for a 4-term, or we don't, I never seen in any textbook where they call these quadnomials. We just call them polynomials in general. Okay? Take this polynomial, 4-term polynomial, and try to subtract off this polynomial here, 2/3 x cubed plus x squared plus 1/2 x minus 3/4. So we're gonna try to subtract these polynomials here. And subtraction involves adding the opposite. So we'll have 5/9 x cubed. It's 1/3 x squared minus 2x plus 1. Subtraction becomes addition, and you add the opposite. So the opposite of positive 2/3 x cubed is minus 2/3 x cubed. Subtracting x squared minusing a positive x squared is turn this into a minus x squared or plus negative x squared, same thing. Subtracting a positive 1/2 x turns this into a minus 1/2 x. Subtracting a negative 3/4 turns this into a plus 3/4. Okay. So subtraction becomes addition, and just change all the signs of all the terms inside the parentheses. Now we're adding like terms together. So we have 5/9 x cubed that needs to get together with negative 2/3 x cubed. One-third x squared. That must be added to negative 1x squared. Negative 2x. That needs to be added to a negative 1/2 x. 1 that gets added to a 3/4. Whenever we add or subtract fractions, we need a common denominator. This is 5/9 x cubed. This is negative 2/3 x cubed. To build this up to an equivalent fraction, we multiply the top and bottom of it by 3. To build this up into a negative 6/9. So negative 6/9 is equivalent to negative 2/3. Common denominator of 3 and 1, because this 1 sits over 1, is 3. So 1/3 x squared minus 1x squared is the same, or plus a negative 1x squared is the same thing as 1/3 x squared plus a negative 3/3 x squared. Negative 3/3, another name for negative 1. Negative 2x plus negative 1/2 x. Common denominator of 1 and 2 is 2. So another name for negative 2 is, if we multiply top and bottom of this by 2, we'll call it negative 4/2 x plus negative 1/2 x. Negative 4/2 is another name for negative 2. Finally, 1 plus 3/4. Common denominator of 1 and 4 is 4. Multiplying top and bottom of 1 by 4. Another name for 1 is to say 4/4. All right. Now what's 5/9 x squared plus a negative 6/9 x squared? What's 5 plus a negative 6? One-third plus a negative 3/3 x squared. You know what? This should be x cubed here. My bad. This should be x cubed. Okay, sorry about that. X cubed. This will be x squared. Negative 4/2 plus negative 1/2 x. And 4/4 plus 3/4. All right, 5 plus a negative 6 is what? Negative 1. 1/3 plus a negative 3/3. 1 plus a negative 3 is negative 2. Negative 2/3 x squared. Negative 4/2 plus a negative 1/2 is negative 5/2. Negative 4 plus negative 1 is negative 5. And 4/4 plus 3/4 is 7/4. Answer. There's your answer. Now, I did show a lot of steps in here. When you get good at doing these, ladies and gentlemen, with practice, you can start omitting some of these subtle steps here, okay? I did lay it all out with all the gory details, but you can speed it up by omitting a couple of these subtle steps here. But nonetheless, this is just showing the process here of adding or subtracting those two polynomials here. So when you add or subtract polynomials, you can only add and subtract like terms. That's the key, only like terms.
Can you turn it back over real quick?
What was that? Okay. Okay.
All right, thank you.
Okay.
This problem is ooh-wee.
Yeah, a lot of fractions. Okay, but I laid all the steps out. You know, I showed all the details. You know, when you get better at this, you can probably cut some corners on this one. You know, it is kind of drawn out there. But I showed all the little itty bitty steps here. So, all right. I have a question here. Is my final answer in descending order? Is this in descending order? Descending order.
Yes.
Yes, it is.
It look like
Yeah,
it.
it is, because this is a third degree term, second degree term, first degree term, 0th degree term. So we would say this is written in descending order. And polynomials are usually always written in descending order. I mean, it's not a huge mistake if you don't have them in descending order. You know, like if you have like 5x squared minus 6x cubed plus 3x minus 9x to the 4th. This is not in descending order. But could I rearrange these terms to get this in descending order? Do you think that's legal to do that? Think I could do that? We certainly should be able to. Just remember, when you move a term of a polynomial from one place to another place, don't forget to bring the sign in front of that monomial. So if I move this 9x to the 4th out front, don't forget that negative sign that pertains to this 9x to the 4th. That has to come out here also. Then we got a minus 6x cubed. Then we have a plus 5x squared. And then we have a plus 3x. This is now in what? That's now in descending order. Agree? So you can always rearrange terms of a polynomial to write it in descending order. Easy thing to do. Just try not to forget the sign in front of the monomial term or the term when you move it. Make sure you bring the sign along with the term when you move it somewhere else in the polynomial. All right. Okay. All right, let's see if we can add and subtract maybe 3 of these polynomials here. So let's try 2y squared minus 7y minus 8. Subtract off 6y squared plus 6y minus 8. And then let's say we want to add that to 4y squared minus 2y plus 3. So we're going to try to, simplify this expression. Instructions may say simplify. Notice we are having to subtract off a polynomial and also add a polynomial. The first thing that you may want to do is go through and change your subtraction to addition. Change subtraction to addition, but then you have to add the opposite of each of these terms. So the opposite of 6y squared The negative 6y squared. The opposite of 6y minus 6y. The opposite of minus 8 plus 8. This is addition, leave it alone. Don't change anything. Now we're having to add together three polynomials. To do so, we can only add together like terms. So this 2y squared will get added to negative 6y squared. And that will get added to a 4y squared. A negative 7y will get added to a negative 6y. And that will get added to a negative 2y. Negative 8 will get added to a positive 8. And then to that, we're going to add a positive 3. So again, I think it's kind of neat if you rearrange your terms and group them together inside separate parentheses. So group them together all your like terms. It just, I don't know, makes it easier to see what you need to do now. So what's 2y squared plus a negative 6y squared?
Negative 4y.
And what's negative 4y squared plus a positive 4y squared?
Is it
It'll
y
just be
squared?
y squared, won't it?
So you added these together first, and you told me you get negative 4y squared. Then to that, we're gonna have to add a positive 4y squared.
So they just be y squared or no?
Well, that's gonna be 0y squared, because negative 4 plus 4 is 0, correct?
Yes.
We say these y squareds cancel out. I'll get that on the next line. What's negative 7y plus a negative 6y? If you want to do two at a time here. These add up to negative 13y. What's negative 8 plus a positive 8?
0.
Now, negative 4y squared plus 4y squared is 0y squared, which means the y squareds cancel out. They're gone. They add up technically to 0y squared, but 0 times anything is 0. So we don't normally write 0y squared. We just get rid of the y squareds. They're gone. We say they cancel out. Negative 13y plus a negative 2y combined to give you a what? A negative 15y. And so therefore, I'll just say minus 15y. Same thing. 0 plus 3 at the end is plus 3. So you know my answer is going to be here? My answer is just going to be negative 15y plus 3. That's it. Negative 15y plus 3. Notice the y squared's gone. It canceled out. Any questions, ladies and gentlemen, how we did that problem there?
I do have a question with the exponents.
The exponents?
Yeah, this I was wondering when we add them, why they stay as a number. I was wondering if there's a reason why they stay as a 2 and not go up or down.
Okay. Here's something we got to be careful with. We don't want to get our wires crossed with our properties of exponents. So ladies and gentlemen, if I take 2x squared and multiply it by 3x squared, what do I get? What's 2x squared times 3x squared?
6x squared.
6x to what power? When we multiply like bases, what do we do with the exponents?
Add them.
We add them. So this should be 6x to the what? 4th power? Here we're multiplying, correct? Multiplying. What happens when you add like terms though? What's 2x squared plus 3x squared? Is it 6x to the 4th? No, 2 plus 3 is 5. Okay, it's 5x to the 4th, correct? Wrong. It's just 5 what?
5x.
5x squared. That's all it is. Do we see the difference between multiplying like bases versus adding like terms? When you add like terms, you do not change the variable part. The variable part does not change. You just add or subtract your coefficients, that's it. When you multiply like bases though, your variable parts will change, correct? X to the fourth. Do we understand the difference between these two different things here? Multiplying versus adding or subtracting?
Yes, same thing.
So we got to keep, we got to try to keep these compartmentalized in our minds and keep them separate so we don't cross these wires. Multiplying like bases together involves we add the exponents. Adding like terms together means we do nothing with the exponents. We leave them alone. Okay? We leave them alone. So just try to make note of this, maybe highlight this in your notes so that, it reminds you of the difference between multiplying like bases versus adding or subtracting like terms. Okay? There's a huge difference. Notice. All right. So I'm going to give you a couple of problems to work with here. I'm going to see if you can do these. We'll call this classwork number 2. Simplify. All right, let's see if we can try this one. X squared plus 5x minus 3x plus 15 plus 6x squared minus 3x. Do that one. And problem number 2, I want you to take x squared, multiply it by 3x, and multiply that by 6 x cubed y. Okay, so classwork number 2.
Mr. L, you hear me?
Yeah, go ahead.
Hey, for the second question, is there supposed to be any pluses or minuses in between that?
No, no, there is not. So what are we gonna do with all these? Number two. There's no plus.
Multiply.
Yeah, it's all multiplication. Mhm. All right, so I put that one in there on purpose and contrast it with number one. All right, problem number one. We have x squared plus 5x. Subtracting 3x plus 15 is like adding negative 3x minus 15. Adding 6x squared minus 3x. All right, like terms that need to be combined here. We have x squared. That must get added to a 6x squared way over here. I have a 5x. Must get added to a negative 3x. Must get added to also another minus 3x here. I got a constant, negative 15, that must get added to nothing. There's nothing to add negative 15 to. Negative 15 has no other like term or constant to be added to, so we just say minus 15. Now, 1x squared plus 6x squared, 7x squared. 5x plus negative 3x is 2x. 2x plus another negative 3x minus 1x minus 15. Anybody get this for a final answer for number one?
Yes, I did.
Yes,
Okay, we got that?
yes.
Now down here, we're doing something entirely different. Here, we're not adding or subtracting polynomials. We're multiplying three monomials together. And we've seen a couple days ago that when you do so, you can multiply their coefficients together. So 1 times 3 times 6. And then you multiply like bases together. X squared times x to the first power times x to the third power. And this y has nothing else to multiply by, so you just bring it along as a factor. Hence, we're left with 1 times 3 times 6 is 18. X to the second times x to the first times x to the third is x to the 2 plus 1 plus 3 power. You add these exponents when you multiply like bases together. 2 plus 1 is 3, 3 plus 3 is 6. And then we got y. Did anybody get that from the last one?
Yes.
All right. Hopefully we can understand and keep them in our minds separate, ladies and gentlemen, how we add or subtract polynomials versus how we multiply, like bases together. Okay. So adding or subtracting like terms is a lot different than multiplying like bases. There's a huge difference, night and day difference. All right. So we got to be careful. So if you got x squared 2x squared plus 3x squared. That's better known as 5x squared. We just combine like terms. But if you have 2x squared times 3x squared, now we're multiplying like bases together. This would give you 6x to the fourth. So try to keep these separate in your mind, these different operations. Otherwise, we get them all mixed up and combined in our mind. It's going to be a real mess. Okay. Got to keep separate, adding or subtracting like terms versus multiplying like bases together. Night and day difference. All right, talk about, speaking about multiplying like bases together, ladies, I'm in the last section tonight is 5.5, in which we're going to begin to learn how to multiply polynomials together. So this is classwork number 2. Multiplying polynomials, section 5.5. All right, we already seen how to multiply monomials together. We tackled that a couple of days ago. So if I have 2x squared multiplied by 5x cubed y squared, to multiply these monomials together, I multiply their coefficients together. 2 times 5 is 10. Multiply like bases together. X squared multiplied by x to the third power is x to the 2 plus 3 power, or x to the fifth power, times y squared. That's how we multiply monomials together. But ladies and gentlemen, how would I multiply a monomial by, let's say, a polynomial in general? So suppose that we want to multiply like 2x by this trinomial. Let's say 15x squared minus 10x plus 7. How do you think I'm going to multiply this monomial by this trinomial? I will have to utilize what property? What property did we use? What property is called the distributive property. So to multiply this monomial by this trinomial, we have to make sure that each term of the trinomial gets multiplied by the monomial. So that's to say that this 2x here is going to have to get multiplied by the 15x squared plus 2x has to get multiplied by the negative 10x. Notice I view that as a negative 10x, so we don't mess the sign up. Plus 2x has to get multiplied way over here by the 7. Now we clean this up. We go back 2 days ago. How do we multiply monomials? We multiply their coefficients. 2 times 15 is 30. X times x squared is x to the 1 plus 2 power, or x cubed. 2x times negative 10x is going to give us a minus 20x what? 20x squared. 2x multiplied by 7 gives us a 14x. Ladies and gentlemen, that is your product of that monomial and that trinomial. So this is the answer when we multiply this monomial by this trinomial. Any questions how we did that? You try one now. You can add this to classwork too. So you try this one. Negative 3x squared y. This monomial multiplied by this monomial. Negative 7xy cubed plus 2x squared plus 5xy. See if you can multiply this monomial by that trinomial. You can add this problem to classwork too. Okay, so see if you can multiply those together. Okay. It's negative 3x squared y. Has to get multiplied into all three of these terms. These arrows are a good visual cue to use, ladies and gentlemen. They help you make sure you cover all the bases. I would strongly recommend using the arrows. All right, what is negative 3x squared y multiplied by negative 7xy cubed? Negative 3 times negative 7 is 21. X to the second power multiplied by x to the first power is x to the 2 plus 1 power, or x cubed. Y to the first power multiplied by y cubed is y to the 1 plus 3, or y to the fourth power. Negative 3x squared y times 2x squared. Negative 3 times 2 is minus 6. You could say plus a negative 6. I'll just say minus 6. X squared times x squared is x to the 2 plus 2, or x to the fourth power. Don't forget the factor of y here. Negative 3x squared multiplied by 5xy. Negative 3 times 5 is minus 15. X squared times x to the first power is x to the third power. Y to the first times y to the first is y to the second power. Did anybody get that correct?
Yes.
Yes.
Notice there's no
Yes.
like terms. There's no like terms to combine in here in the end. Sometimes there might be like terms that you have to combine after you do your multiplications, but none of these are like terms. So we stop our problem here and call it our answer. Okay. So I have shown you now how to multiply a monomial, okay, a monomial by a polynomial. What happens if we want to multiply two binomials together? Two binomials. How would you multiply two binomials together? Well, we'll tackle that next. All right, so what I'm going to show you, ladies and gentlemen, is in general, how do we multiply two binomials together? Like in general, if I have A plus B, and I want to multiply that by C plus D. In general, how do we multiply two binomials together? There's many, many, many ways to show how to multiply two binomials together. I'm just going to show you a couple of ways and let you decide which way you want to go. You know, I don't think it's advantageous to work these problems out 10 different ways. Okay. But what I'm going to show you is probably the most popular orthodox ways of multiplying binomials together that are talked about in most textbooks. All right, the first method for multiplying two binomials out, ladies and gentlemen, is called the FOIL method. And you will see why we call it the FOIL method. This is a very popular way to multiply binomials together, the FOIL method. All right, why do they call it the FOIL method? Well, here's what we do. We start off by taking the product of the first terms of our binomial. So A, being the first term of the first binomial, gets multiplied by the first term of the second binomial, C. So A gets multiplied by C. A times C is AC. This represents the product of the first terms. Then we're going to multiply the outer terms of our binomials together. Those are the terms that are furthest apart from each other. A and D are called the outer terms of these binomials. A will get multiplied by D. Plus A times D is AD. That represents the product of the outer terms. Then we multiply the inner terms of our binomials together. The B gets multiplied by the C here. B times C plus BC. That's the product of the inner terms. Then we multiply the last terms of our binomials together. B gets multiplied by D. B times D is BD, so plus BD. This is the product of the last terms. And notice you get the word FOIL, F-O-I-L, FOIL. FOIL stands for the product of the first terms plus the product of the outer terms plus the product of the inner terms plus the product of the last terms. The product of the product of the first terms, the outer terms, inner terms, last terms. Everybody see what we just did there? That's called the FOIL method. That's a very popular way to multiply two binomials together. Notice when you take a two-term polynomial and multiply it by a two-term polynomial, 2 times 2 means you get 4 products. 4 products. And notice we did get 4 products. 1, 2, 3, 4. You also see 4 arrows. 1, 2, 3, 4. So when you multiply a two-term polynomial by a two-term polynomial, you always get 4 products. 4 arrows will show in your diagram, okay, or your paper. That's called the FOIL method for multiplying binomials together. It is a very popular way to multiply binomials together. It's the most talked about way in just about every textbook that you will look at in algebra and beyond. So let's see if we can employ the FOIL method to multiply a couple binomials together. So we'll try to multiply, how about x plus 2 multiplied by x minus 6. We will try to multiply these two binomials together. All right. To do so, ladies and gentlemen, we take the product of our first term. So x gets multiplied by x. X times x. That's the product of your first terms. F for first. Multiply the outer terms together. X times negative 6 plus x multiplied by negative 6. Product of your outer terms, O for outer. Then we multiply our inner terms together, 2 times x. That represents the product of our inner terms. Plus, then we multiply our last terms together, 2 times a negative 6. Notice I always put a plus sign between my products, always, to remain consistent. Okay. Now we clean this up. What's x times x? Is x times x 2x or x squared, or does it matter?
Times 1 is
X squared.
X squared. Thank you. X times x, ladies and gentlemen, is x squared. It is not equal to 2x. This is not x plus x. This is x times x. This is not equal to 2x. It's equal to x squared. Again, don't cross the wires between combining like terms versus multiplying like bases. X plus x is 2x, not x times x, which is x squared. There's a night and day difference between 2x and x squared. They're not even close to being equal to each other. All right, so x times x is x squared. What's x times a negative 6? What's 1x multiplied by a negative 6?
negative 6x.
Minus 6x. What's 2 times a 1x, or 2 times x? 2 multiplied by x plus a 2x. 2 multiplied by a negative 6 plus a negative 12, or we can just say minus 12, same thing. Now, are there any like terms that should be combined in here? Don't leave your answers, ladies and gentlemen, with like terms uncombined. Always try to combine like terms. Do I have any like terms in here that need to be combined?
Negative 6x plus 2x.
These are like terms. Please do combine them. This is not considered to be simplified. So we have x squared, a negative 6x added to a 2x. Negative 6 plus 2 is a minus 4. So minus 4x is what these x terms combine to give us. It's not minus 4x squared. We're not multiplying x times x. We're adding like terms together. negative 6x plus 2x, you keep the variable part the same. You don't change anything on the variable part when you combine like terms. Minus the 12. There you go. That would be your simplified product of these two binomials. And what method did I show you here? What technique has been illustrated here, ladies and gentlemen, for multiplying these binomials together? We have a name for it. It's called the what method?
FOIL.
FOIL method. It's a very popular technique that's shown in all algebra books. How to multiply two binomials together. You multiply the first terms together, the outer terms, the inner terms, the last terms. That's how it works, okay? That's a popular way to multiply binomials together. I am going to show you one other way, and I'll let you decide which method you want to go with. All right. The FOIL method is a pretty streamlined way of doing things, okay? There is another way, ladies and gentlemen. It is called the, what does your author call it? I think your author calls it the, let's see here. The rectangle way. The rectangle method for multiplying binomials together or polynomials together in general. We're going to rework this problem, but I'm going to show you how to do it with the rectangle method. The rectangle method, or sometimes it's called the table method, would have me putting one of these binomials for my rows of my table or a rectangle here. So x plus 2, I could put the x here and the plus 2 here. Then up here, I'm going to put my other binomial to constitute the columns. So I would have like the x minus 6. So I would say the x here and the minus 6 here. So this is kind of like a multiplication table. Think of it that way. What's x times x? X times x is x squared. X multiplied by negative 6, negative 6x. 2 times x, 2x. 2 multiplied by negative 6, minus 12. You see that there? It's called the rectangle method. Now, do we have any like terms that need to be combined in here? Well, these are like terms here. The negative 6x and 2x should be added together. And so therefore, we would write our answer as x squared, 2x plus a negative 6x is a minus 4x. And then we got the minus 12. That's called the rectangle method. Anybody see how we did the rectangle method here? Now it doesn't matter. You could have put the x and the minus 6 here and the x plus 2 here. Doesn't matter. It's kind of like the rectangle method or the table method for multiplying polynomials together. So in all honesty, in all the math books I've ever seen, I've seen quite a few, the FOIL method is the most orthodox way of showing how to multiply binomials together. The product of the first terms, the outer terms, inner terms, last terms, okay? All right, so I'll let you decide whether you use that or the table or rectangle method. It's up to you. The bottom line is we got to get it correct in the end, either way you go or either way you choose to do things, all right? All right, let's try to multiply a couple more binomials together. Let's try, all right, let's try to multiply these together. Okay, let's try this. If I have 2x minus 5, and I want to multiply that by negative 3x plus 10. I want to multiply these two binomials together. FOIL method works okay. Multiply the first terms together, 2x multiplied by negative 3x. Now, when you get better at this, ladies and gentlemen, you don't even have to show this next step that I'm showing. When you get good at this, you can just do this in your mind. 2x times negative 3x, negative 6x squared. 2x times 10 plus 20x. Negative 5 times negative 3x plus 15x. Negative 5 times 10 minus 50. But for now, I'll show this intermediate step. So we take the product of the first terms. 2x gets multiplied by the negative 3x. That's the product of the first terms. Plus the product of the outer terms. 2x gets multiplied by the 10 way over here. product of the outer terms, plus product of the inner terms, -5 times -3x. That's the product of the inner terms. Plus the product of the last terms, -5 gets multiplied by 10. So what's the product of 2x and -3x? What's 2x times -3x? Anybody?
-6x.
Right. You got -6x.
Square.
Yeah, what's x times x? X times x is x squared. All right. What's a 2x multiplied by a 10?
20x.
20x. -5 multiplied by a -3x.
15x.
-5 times 10.
-50.
-5, 0. Right? Combining like terms. The two middle terms are like terms. They need to be combined. So we're going to have -6x squared. What's 20x plus? This is plus, not times, plus 15x. Plus a 35, what? X. Not x squared. We're not doing x times x. We're just adding like terms together. We're not multiplying like bases together. It's just 35x minus 50. And that's it. There's nothing else you can do. That would be your simplified product of those two binomials. Does anybody want to see the rectangle or the table method for doing this problem?
Nope.
Nobody. Okay. You can use the method if you want, ladies and gentlemen. In all honesty, the FOIL method, this really is the most streamlined way of doing it, the most streamlined way, the most efficient way. The table method consumes a lot of paper because, you got to make your table. You can use the table method. There's nothing wrong in doing that, I don't have anything against it. If you want to use that method, go ahead. That's all right. The FOIL method really is the most kind of like the more orthodox way of doing it, though, in general. Okay.
Is that what those in the graph, well, the tables problems in our homework, was that basically what they were asking us to do?
I believe, yes, I believe that's what they were wanting you to do.
Was
Now,
the table method? I think it was homework 5.2. There was
5.2.
there was a like a couple table.
Yeah,
So-
I'm flipping back to 5.2. I just want to take a look here quickly and see like what you're referring to. Oh, kind of like these problems here with the tables.
Yep, that one.
All right, no, that's just something different. Okay, they just want you to take some numbers here and just kind of like square the numbers and then cube the numbers. That's it. This is something
okay.
entirely different. We're not multiplying polynomials together here. Okay, that's something entirely different. Yeah. All right, ladies and gentlemen. What do you think? I mean, do you think you're ready to try a couple of multiplications with some binomials? Think you're ready to try a couple on your own, multiply a couple binomials together?
Yeah.
Just remember in the end that if you have any like terms to combine after you multiply things together, make sure you combine your like terms in the end. That's very important there. All right. All right, I'm going to give you some binomials to multiply together. Let's see if you can do some of these here. We'll call this classwork number 3. And for each of these, I would like you to multiply all these together. So problem number 1, I would like you to see if you can take t minus 8 and multiply it by t plus 2. Problem number 2. I would like you to try to see if you can take 6x plus 5 and multiply that by 6x minus 5. Problem number 3. See if you can multiply 3x plus 6 times 2x minus 1. And the last problem, number 4. Oh, challenge problem. Fractions. How about W minus 1/2 multiplied by, how about W plus 5/2? Let's see if you can do something with that fraction problem in the end, ladies. And we'll call this classwork number 3. Have at it and we'll All right, let's take a look at a couple of these here and see if you had any success. First one, we got T times T. What is T times T?
T to the second power.
Now multiplying the outer terms together. T multiplied by 2 plus 2t. Multiply the inner terms together. -8 multiplied by t minus 8t. Multiply the last terms together. -8 multiplied by 2. -8 multiplied by 2 minus 16. Combine your two middle like terms. Did you get for an answer t squared minus 6t minus 16? Did we all get that for a product?
Yes.
Yes.
Okay. Anybody that did not get that? All right. Let's try the other. Notice this is written in descending order, isn't it? Descending order. The degrees of the terms decrease from left to right. Trying this one, what's 6x multiplied by 6x?
36x squared.
36x squared. Multiplying the outer terms together, 6x gets multiplied by -5. 6x multiplied by a -5 minus 30 what? X. Multiply the inner terms together, 5 times 6x plus 30x. What's 5 multiplied by -5?
Minus 25.
Minus 25. Notice the middle terms combine. What happens to the middle terms? What is a -30x plus 30x?
They cancel out.
They're gone. They add up to 0x, which means they're out of the picture. We're left with 36x squared
Minus 25.
minus 25. Did anybody get that?
Yes.
Again,
Yes.
right, that'd be the product of those two binomials. All right, let's try this one here. Multiplying the first terms together, 3x times 2x, 6x squared. Don't forget to say x times x is x squared. 3x multiplied by -1 way over here. 3x multiplied by a -1 minus 3x. Multiply the inner terms together. 6 multiplied by 2x plus 12x. Multiply the last terms together. 6 multiplied by a -1 minus 6. Combine the middle two like terms. So we'll have 6x squared. What's a -3x plus 12x?
9x.
Plus a 9x. And then minus your 6. That's your answer for that one. Are we batting 1,000 out there so far?
So far, yeah.
Yes.
All right, now we got a nasty one here, some fractions, but nothing changes. We still pursue it the same way. Multiply the first terms together, w times w, w squared. W multiplied by 5 halves is plus 5 halves w. Multiply the inner terms together, -1/2 times w, minus 1/2 w. Finally, the last terms, what's a -1/2 multiplied by 5 halves? Negative times a positive is a minus. 1/2 times 5 halves. 1 times 5 is 5. 2 times 2 is what? 4? Correct? -1/2 multiplied by 5 halves, -5/4. Middle terms are like terms that need to be combined. Hey, we're lucky. We have a common denominator already. So what's 5 halves w? Subtract 1/2 w. What's 5 minus 1?
4.
So we'll have plus 4 halves w minus the 5/4. Finally, feel free to reduce 4 over 2 down to what? Just 2? Final answer, w squared plus 2w minus 5/4. Did anybody persevere to the end and get that one?
I did.
Well, congratulations. All right, so we're multiplying some binomials here together using the FOIL algorithm or the FOIL method. All righty. Anybody see how we're multiplying binomials together here? Okay, and I will give you an appreciable amount of practice in your homework, so make sure that you do indeed try to do as much of the practice as, you know, time warrants in your personal life, ladies and gentlemen. All right, let's see here. Let's raise the bar here a little bit as we begin to close the door here on this section. Let's see if we can take a binomial and multiply it by a trinomial. That should be interesting. Let's try one out here. Let's try this. X plus 5. Let's take this binomial and see if we can multiply it by this trinomial. X squared plus 2x minus 3. So now we're going to go top gun here, ladies and gentlemen. We're going to try to multiply a binomial by a trinomial. So we're really going to up the ante here, if you will. All right. Now, how are we going to multiply a binomial by a trinomial? Well, unfortunately, there's no nifty word that like FOIL we can attach to this process, like when we multiply two binomials together. The bottom line is, when we multiply a polynomial times another polynomial, you just got to make sure that each term of the first polynomial gets multiplied by all the terms of the second polynomial. That is important. And so I have a 2-term polynomial being multiplied by a 3-term polynomial. So I would expect to get how many products? What's 2 times 3? I would expect, ladies and gentlemen, to get 6 products when I get done multiplying these out. Or I would expect to see 6 arrows. I better see 6 arrows in my picture when I get done. Here we go. I'm going to make sure this first term in my binomial here gets multiplied by all 3 of these terms. So we start off by taking x times x squared. Please do use these arrows as a visual cue. What is x multiplied? Well, tell you what, I'm going to show this intermediate long step here. Some people might need to see it before we take the training wheels off. So we got x times x squared. Plus this x now is going to come over here and get multiplied by the 2x. Plus, now the x comes over here and gets multiplied by the -3 way over here. Plus, we're done with the x. We've exhausted all the products with x in the second polynomial. I have 3 arrows coming out of it. That means I multiplied the x by this term, and this term. We're good. Move over to the 5 now. Now the positive 5 gets multiplied by all 3 of these terms. 5 times x squared. Plus 5 gets multiplied by 2x. Plus 5 gets multiplied by the -3 way over here. I've exhausted all the products with the second term of my binomial. Ladies and gentlemen, do I have 6 products? 1, 2, 3, 4, 5, 6 products as predicted. Do I see 6 arrows? 1, 2, 3, 4, 5, 6 arrows. We're good. We covered all the bases. Now we just got to clean this up. What's x times x squared? X times x squared, as we multiply these like bases together, we add the exponent. So x times x squared.
Cubed.
X cubed. What's x to the first times 2x?
X squared.
2x squared.
Plus 2x squared. What's a 1x multiplied by -3?
-3x.
Minus 3x. Plus a 5x squared. 5 multiplied by 2x is plus a 10x. 5 multiplied by -3 minus 15. Everybody understand? 1, 2, 3, 4, 5, 6 products. Do you agree? Now, are there any like terms that need to be combined? Please don't leave your answer looking like this if there's like terms that are in need of being combined. Always combine like terms in the end. X cubed.
5x
Yeah.
squared.
X cubed has nothing to combine with. But do you agree the 2x squared needs to be added to what, a 5x squared? What is 2x squared added to 5x squared?
X to
2x squared plus 5x squared is plus a
7x to the 4th.
7x squared. You know, when I was in school taking algebra, after I combined like terms, I would put a real light little slash mark through them indicating that they've been dealt with. That's a visual cue for myself, indicating I've already combined my second degree terms. I got 7x squared. Now the first degree terms. What's a negative 3x plus a 10x? A negative 3x added to 10x. What's negative 3 plus 10?
7.
Plus a 7 what? 7,
X.
7x plus 7x. I combine my first degree terms, done with those. And then we just have a constant term at the end that has nothing to combine with, but don't lose it. You still got to bring it down as part of your answer. Finally, ladies and gentlemen, notice there's nothing else I can do. There's no other like terms that need to be combined. This is my answer, and is my answer in descending order?
Yes, it is.
Third degree term, second degree term, first degree term, 0 degree term. It's in descending order. That's your answer. Any questions how I just multiplied this binomial by this trinomial? Could you use the rectangle or the box method to do this problem? Yes, you could. Anybody want to see the box or the rectangle method?
No.
Nobody wants to see that method? Okay, then I guess we'll let it just be as is. Ladies and gentlemen, do you want to try one on your own? This will be the last classwork number 4. I will give you a binomial and have you multiply it by a trinomial. See if you can do this problem. Do it the same way I did this one up here. Nothing changes. All right, I would like you to try to take t plus 5 and multiply it by t squared plus 2t minus 7. Go ahead, see if you can multiply this binomial and this trinomial. Let's see if we can get that accomplished. This will probably be your last classwork today. All right, let's take a look. T times T squared. T to the first power multiplied by T to the second power is T to the third power, T cubed. T times 2T. T multiplied by 2T is 2T squared. T gets multiplied by the -7. T multiplied by -7 minus 7T. Done with the T, move over to the 5. 5 times 1T squared plus 5T squared. 5 multiplied by 2T plus 10T. 5 multiplied by -7 minus 35. 6 products, 6 arrows. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 arrows. We covered all the bases. A 2-termer times a 3-termer. 6 arrows, 6 products. Combined like terms, we got T cubed. What's 2T squared added to 5T squared? Plus 7T squared. What's a -7T plus 10T? -7 plus 10 is plus 3, plus 3T. Finally, so we combined our second degree terms, our first degree terms, and we have a constant term at the end that has nothing to combine with. How many people actually got that correct answer in the end? Anybody?
I got
I
it.
did.
I did.
Congratulations, ladies and gentlemen. You know how to multiply polynomials together. I'll give you some more practice in your homework. And I also give you the solutions, don't I? For odds and evens. So if you want to do more practice, go above and beyond what I assign you. There's more problems in your book. By all means, go ahead and do some more. You can always check your answers, or if you get snagged, you can check the solutions that I post. So there's ample practice. All you have to do is take the initiative and actually do the practice. That's the toughest part, unfortunately, though. All right, ladies and gentlemen, I'm going to let you go. You have a great weekend, and hopefully I'll see you next week. Next week's our last full week before Thanksgiving, isn't it?
Yes.
You can tell I've been counting them down. All right. You can tell, can't
Me
you?
too.
Yeah, I tell you, I mean, I'm getting frazzled here. I need just a little smidgen of a break here, but okay. Any other questions or comments? I will stay on the line for a couple of minutes. If not, have a nice one, ladies and gentlemen.